So section 4.1 is on ordered pairs and graphs. So ordered pairs are just points, x, comma, y. Hey, Jake. So the Cartesian coordinate plane is also known as the rectangular coordinate plane. And it's created by René Descartes. Have you guys heard of René Descartes before?
No.
He's the guy that said, I think, therefore I am. Have you ever heard that before?
Oh.
No? Okay. And it was created in 1637. So the story goes, so I'm guessing this is true, I don't know, is that he was laying in bed one day and he looked up at the ceiling. So if you look up at the ceiling of our classroom, it's actually like this. Do you guys see how we have a grid on our ceiling? And there was a fly that was buzzing back and forth. And he was like, I wonder if I could estimate the distance that the fly has traveled using these ceiling tiles to help me. Okay, so he came up with a Cartesian coordinate plane that way. Guys, computers away, please. So that's why it's called Cartesian, Descartes, Cartesian coordinate plane. Yes?
So, pertaining to grids, I learned this on Thursday, that Indianapolis and Washington, D.C.
are on grids, yes.
Planned out
Definitely.
to be in a grid.
Yes, so if you notice, when you go to Washington, D.C., you have, A Street, B Street, C Street, D Street, and then 1, 2, first, second, third, fourth. It is definitely on a grid. So, yes, sometimes cities are built on a grid. Indianapolis is, definitely. All right, so we use an ordered pair of numbers, x and y, to represent the distance along the x and y axis. So you have a point here. So you guys see how we have 2, 3? So that 2, 3 means that we go over 2 spaces. So if you go over 2 little swoops here, and then you go up 1, 2, 3 spaces. Notice how I'm counting the spaces, not the lines. Guys, what is with your computers? Put your computers away. So we are going spaces, not lines. So don't go 1, 2 like that, and then 1, 2, 3 like that. A lot of people in Algebra 1 will mess that up. So spaces, not lines. The coordinate plane is divided into 4 what we call quadrants. Quad means 4. So we have quadrant 1, quadrant 2, 3, and 4. So quadrant 1 starts out with a positive x and y. So quadrant 1 is right here. Quadrant 2 is right here. 3, and then 4. Okay? And then the point 0, 0 has a special name. So 0, 0 is called the origin. Okay, so have you all seen this before? Pretty familiar. Okay. So it says graph all of the points on the coordinate plane below and label the points with the given letter. Okay, so if I have 3, 6, I'm going to go over 3 spaces, over 1, 2, 3, up 1, 2, 3, 4, 5, 6, and my point would be right here. Okay, so that's going to be our letter A. So I'm showing you this in red, but we don't obviously do that when we're graphing, do those little spaces like that. All right, and then B is going to be negative 4, 5. So we're going to go over negative 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5, and that's going to be B. All right, C is going to be 0, 7. So I go over 0 and I go up 7. 1, 2, 3, 4, 5, 6, 7, and that's going to be C. All right, you guys need to take your earbuds out too. This is very frustrating when I have to tell you this every single day. Frustrating that I have to tell you to take your computers away, put your computers away. Frustrating that I have to say put your phones away. All right, D is going to be negative 2, negative 8. Negative 2, 1, 2, 3, 4, 5, 6, 7, 8. So it should be down here. And then E is negative 3, 0. So it should be right here. Okay, so I'm guessing that you guys all kind of remember that from algebra or from pre-algebra. Did you guys all do that in pre-algebra? Nope, you never did? Okay, well, it's new. All right, do we understand how to graph points? You get it? Okay. So for number 2, it's a little bit more challenging. So it says graph 6 points for the equation y equals 3x plus 4 by using a table of values. So sometimes I'll call a table of values a t-table. That's how I learned it when I was growing up. Okay, so with this t-table, and we say it because it makes a big T, we would put in values for x, and we're going to get values for y. So values for x, we usually want them to be kind of small. So I would plug in 0, 1, and 2. But I also always want to plug in some negatives too. So I'm going to plug in 0, 1, and 2, but I'm also going to plug in negative 1, negative 2. And then, I don't know, what else you guys want to try? Negative 3. We'll do that. It doesn't have to be those points. It can really be anything. So if I plug in 0 into y equals 3x plus 4. So I'm plugging in 0 for x. Can you guys all do that in your head? 3 times 0 is 0 plus 4 is 4. 4, exactly. So we're going to get 4 here. So the next one is going to be 3 times 1 plus 4. So 3 times 1 is 3 plus 4 is
7.
7. And then 2, 3 times 2
6.
plus 4,
10.
10, exactly. So now let's do the ones that are negative. So I'm going to have 3 times negative 1 is negative 3, and then plus 4.
1.
Yeah, a little bit harder though, isn't it? Negative 3 plus 4, so 1. So if you need to do like some work off to the side like I'm doing, you can always do that. So negative 2, I'm going to have negative 6 plus 4. So negative 6 plus 4 is negative 2. And negative 3, I'm going to have negative 9 plus 4, which is negative 5. So when I plot these points, I'm going to have 0, 4. So I'll go over 0, up 4. You don't get the 0, 4? Okay, this goes together as a point here. You didn't get how to put the numbers into the t-table? Is that what you're saying? Where did I lose you, Peter? Okay, did you understand how I got all the numbers that are in the chart? No. Okay, so I'm plugging in. So when you set up a t-table, what we do is we do x and then we do y. So let me do a couple more points. So if I plug in any number for x, so let's say I plug in 5. I'm plugging it into this equation, y equals 3x plus 4. So I'm going to have y equals 3 times 5 plus 4. I'm replacing the x with what it's equal to. So x equals 5. So I'm going to have 3 times 5 is 15. And then plus 4 would be 19. So y would be 19. And that's going to go together as a point. It's going to be the point 5, 19, like that. So then you would plot 5, 19. Now 19 is off of our chart. Okay, that's why I was saying you probably want to pick numbers that are kind of small. So if you picked like positive 3, then we'd have 3 times 3, right? We're plugging in 3 for x. And then we add the 4 to it. So we're plugging in right here for x. So 3 times 3 would be 9. 9 plus 4 is 13. So we'd have 3, 13 that we'd graph. Do you see that? We good there? All right, and then when we graph the points, so we're thinking of each of these as x, y. So like this first one is going to be 0, 4. So I go over 0 and up 1, 2, 3, 4 right there. So when I have something like 1, 7, I go over, this is the positive x direction. I go over along the x-axis 1, and then I go up 1, 2, 3, 4, 5, 6, 7. Hard to draw. Okay, so that's the next point. And then my 2, 10, I go over 2, and then up 10. So that's up at the very top. But when I have negative, so if I have negative x, I'm going to go backwards along the x-axis. So I'm going to go back 1 and then up a positive 1. So it's going to be right there. And notice how all of these are kind of forming a line. All right, so I'm going to have negative 2. So go back 2 and then down 2. So it's negative 2, negative 2. And then negative 3, negative 5. So I go backwards 3 and then down 5. So 1, 2, 3, and then 1, 2, 3, 4, 5 down there. So those are our 6 points. So this equation then forms a line, right? So we would then draw the line in. So we don't always need 6 points to draw a line. You really only need 2 to draw a line, but we're going to practice graphing these. Okay, so let's try another one like that, because that's kind of weird. So it says graph 6 solution points for the equation 2x plus y equals 6. Now on that last one, it was kind of nice because we had y equals. This one we don't have y equals. Do you guys think we can get the y by itself?
Yes.
Yeah, how do I get rid of the 2x?
Divide by.
That's how I get rid of a 2, right? Subtract it over. So we're going to subtract it over. So if we have 2x plus y equals 6 and we want to get the y by itself, we subtract our 2x and subtract our 2x. Now, 6 minus 2x is not 4x, right? How do I do 6 minus 2x? You can just leave it, right? 6 minus 2x. So the way we usually will write this is we'll do the x part first. So we would do negative 2x plus 6, but that's fine. If you guys want to do 6 minus 2x, it works as well. We'll talk about why we would write with the x first in the next couple sections. All right, so pick some numbers that would be good to pick. Okay, so 0 is always good, right? Plugging in 0 for x. What happens when I plug in 0 for x? What do I get?
0.
I get 2 times 0 is 0, so I have 6 minus 0, which is 6. So I have 0, 6. Are we able to graph that point? 0, 6. That means go over 0, up 6. So we're going to go up 1, 2, 3, 4, 5, 6 along the y-axis. So this is called the x-axis, and this is called the y-axis. All right, so the next one. If I plug in 1, I'm going to get y equals 6 minus 2 times 1. So what's 2 times 1? 2. 6 minus 2?
4.
Exactly. So that next one's going to be, when I plug in 1, I got 4 out. So we're going to graph 1, 4. So go over 1, swoop, go up 1, 2, 3, 4 swoops. All right, same idea. Can you guys start to do some of these in your head? What if I plug in 2? What do I get? I'm plugging in right here.
2.
Yeah, I get 2. 6 minus 4, right, is going to be 2. So I have 2, 2. What do I get when I plug in 3? 0. And you could plug in negatives as well. It's a little bit tricky when you plug in negatives here. So if I plug in, let's say, -1, I'd have -2 times -1. Well, what is -2 times -1?
2.
2. So it's really going to become 6 plus 2, which is 8, because the -2 times -1 becomes positive 8. Or positive, positive 2, which makes 8. All right, so if I plug in -1, I get 8. What about if I plug in -2? I'd have 6 minus 2 times -2. So 6 plus 4, which is 10, exactly. So I'm going to have -1, 8, -2, 10. So all the ones that you're going to have so far on your homework and stuff, these are all going to be lines. So if you're not getting points that are forming a line, you've done something wrong. So sometimes, you know, I'll have students that will have they have these first 5 work, and then one's way up here. And they're like, wait, what happened? So then check that one weird point, right? So this does make a line. So we can draw that. All right, so how about this one? If I want to solve for y, it's a little bit trickier because now I have 2y, right? So I'm going to have 2y minus 4 equals x. I could add the 4 over. So I have 2y equals x plus 4. Now how do I get the y completely by itself? Divide by 2. So I could write it as y equals x plus 4 all over 2 and just do it that way. Or I could take the 2 into both pieces and I could say y equals 1/2 x plus 2. So I divided the 2 into both parts. So I did x over 2 plus 4 over 2. Oops, it's kind of messy. Okay, do you guys understand what I did there? It's like the opposite of getting common denominators. I broke it apart so that they were separate fractions. If I wanted to combine them, they now have common denominators, so I get x plus 4 all over is equal to, which was back there. Okay, so let's try this. If I have 1/2 x plus 2, I don't want to try numbers like 3 for my x. Do you guys see why I don't want to try 3? 1/2 of 3, ugh. Now I have a decimal or a fraction, right? I don't want to do that. So what would be good numbers to try for my x? Yeah, so let's try 0, 2, 4, maybe 6, -2, -4. Try some negatives as well. All right, so see if you guys can get the right side of that t-table correct. So go ahead and plug in those numbers. So plug in 0, plug in 2, plug in 4, see what you get. All right, so when you plug in 0, you should get y equals 2. Did you guys all get that? When you plug in 2, you have 1/2 of 2 is 1, plus 2 gives you 3. When you plug in 4, you get 1/2 of 4 is 2, plus 2 is 4. When you plug in 6, you get 1/2 of 6 is 3, plus 2 is 5. When you plug in -2, 1/2 of -2 is -1, plus 2 is 1. And when you plug in -4, you get 1/2 of -4 is -2, plus 2 is 0. So when you plot these points, you have 0, 2. So go over 0 and you go up 2. So we have that point. 2, 3, 4, 4. Oops, I didn't go 2, 3, did I? You could have gotten a bonus point. All right, 2, 3, go over 2, up 3. 4, 4, go over 4, up 4. 6, 5, go over 6, up 5. And it kind of follows the same pattern. If I go negative 2, 1, it goes back to negative 2, so left 2, up 1. And negative 4, 0 goes left 4, up 0. So did we all have the same line on our graphs? You guys all have that? And we draw them. All right. Feeling okay with those now? All right, good. So we're going to do a lot of T-table stuff in the next couple sections. So make sure you're kind of used to that. Yeah. Yeah, you could get 2 and kind of follow a pattern, but what if the first 2 you got are wrong? Yeah, so if I say on the homework, like, graph 6 solution points, make sure you're graphing 6. Yeah. Our calculators do know how to do that, but are you going to be smart enough to put it in the calculator yet? I don't know. Still got to do all that work to get it in y equals. All right, so decide whether or not the following points are solutions to the equation. So if I have y equals 2x minus 5, let's decide if these points work in the original equation. So if I plug in negative 1, do I get negative 7 out? So let's try. If I plug in negative 1 for x, I want to see if this makes a true statement. So a lot of times if I'm seeing if it's a true statement, I put a little question mark over my equal sign because I'm not sure. So I plugged in x equals negative 1 and I plugged in y equals negative 7. I want to see if it's true. So is that true? Negative 2 minus 5, is that equal to negative 7? Yes. So what does that mean? That it is on the line, right? So this point is on the line. So if I plug in negative 5 for x, do I get 0 for y? So 0, is that equal to 2 times negative 5 minus 5? Negative 10 minus 5, is that equal 0? No, it doesn't work, right? So we just go through and we decide if these work. So how about if I plug in 0 for x? Do I get negative 5 for y? Can you guys do it in your head? Yeah, it works. What if I plug in 1 for x? Do I get 3?
No.
No, what do I actually get?
It did not work.
If I plug in 1 for x, what do I get? Negative 3.
Negative 3.
You see it? So this one doesn't work. And if I plug in 3 for x, do I get 1 for y?
Yes.
Yeah, this works. Okay, so you're just plugging in to see if it makes a true equation or not. Okay, and then the last ones we have are going to involve some area type things. Okay, so we're going to plot all these points. So it says plot the points and find the area of the figure formed. So whenever we have like A, B, C, D, we're going to graph in alphabetical order. So if I don't specify graph A, B, C, and D, like by connecting the points A to B, B to C. Okay, so I have negative 2, 5. So negative 2, 1, 2, 3, 4, 5. It's up there. So left 2, up 5. And we're going to mark that as A. B is negative 2, negative 3. So negative 2, 1, 2, 3. That's B. C is 4, negative 3. So over 1, 2, 3, 4 to the right, down 1, 2, 3. And D is 4, 5. So go over 4 and up 1, 2, 3, 4, 5. D. So if I connect A to B, B to C, C to D, and then D to A, what shape do I have?
Rectangle.
A rectangle, right? So if I have a rectangle, its area is going to be length times width, or base times height. Doesn't matter. Xavier. All right, so we want to find the length and the width. So I want to find how many units tall that is. Well, how do I find that? I could do it in a couple different ways. Okay. One thing to do is if you have the graph, just find the number of spaces between those. So if I'm counting the number of spaces, right, these little bumps, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. Do you guys see that? Another way that you could do it is you could say, well, I was at a height of 5 and I went down to a height of negative 3. So if I'm starting at 5 up on the top and I go all the way down to negative 3, wouldn't that make sense that it's 8 spaces? 5 minus a negative 3 would be 8. Yeah. So that's going to be 8 units. How about this one? So if I count the number of spaces, 1, 2, 3, 4, 5, 6. So let's think about why that makes sense. Well, my x values went from negative 2 all the way over to 4. So if I start at -2 and I go over to 4, is then a total of 6 units. Yeah, so that's going to be 6. So my area then is going to be 8 times 6, which is going to be 48. And since we don't know what units we have, we would just say like units squared for an area. All right, does that make sense? All right, so let's try another one. So this one only has 3 points. So what shape is it probably going to form? A triangle. So let's figure it out. So I'm going to have -5, comma, -2. That's going to be x. Y is 3, comma, -2. So over 3 down 2. And z is 1, comma, 6. It's a little tricky. So we know that the area of a triangle is the base times the height. Okay, so the base, well, not base times height, 1/2 base times height, right? So we need to figure out what the base and the height is. Our height is always perpendicular to the base. So think about this as a mountain, and the mountain has a ground. The base is your ground. If you go directly up to the tip of the mountain, your height is right here. Do we see that? So we need to figure out how many units long our base is and how many units long our height is. So our base goes over 1, 2, 3, 4, 5, 6, 7, 8 units. And our height goes up 1, 2, 3, 4, 5, 6, 7, 8 units. And we still have that 1/2 from before. So what is my area? What do you think, Will? 32. Yep, 32. So 64 divided by 2, or half of 8 is 4. 4 times 8 is 32. So it's 32 units squared. Exactly. Okay, think you can handle those as well? All right. So let me stop here.